Hi, welcome in this lesson where we are going to see different data terms. So after all, we are working in data systems, and in the end it's always something about data. So we will see here various data like terms that should help you at least do the first steps in data engineering world. The first of the terms is, of course, data engineering. I answered it a little bit earlier in this module in who a data engineer is lesson, but still here I will just give you a more concise definition, which consists of building systems to store, to collect, store and expose data for various use cases in data world, maybe for data analyst, data scientist, or even backend engineers if for whatever reason they would like to use your data in their APIs. So this one is the most challenging one, not in definition because it actually defines how good your data is for your final goal, but in practice because it's very hard to keep data of a good quality. And especially if you are working in a big organization where there are different data production teams that cannot necessarily synchronize each other and might introduce different data quality issues like null values in some required fields or inconsistent schemas in the same data generation or stuff like that. So data governance is a little bit related because it's a process that defines the rules for managing data availability, data usability, data integrity, and data security. So with data quality, you know that your data set can be trusted, but without the data governance, you don't know where the data set that can be trusted is located. So data governance is something that will help evangelize about this data set and also ensure that correct people have access to it. And this security aspect helps me to move smoothly to the next term, which is data security. So data security defines who can access the data, but not only. Data security also groups things like encryption, storage in motion. It also covers things like data security in terms of data loss, because you can have a storage and if someone makes an erroneous operation, he or she can delete the data you have, and if you can define an appropriate data security policy to not make this happen or to mitigate the risk. Another thing is data observability. Data observability is an equation composed of metrics, traces, and logs. So here the goal is to be more aware of what's happening with this data in the data system. So it of course includes things like monitoring layer, like alerting layer, and also should integrate with all the data quality watches that you may add to the system in order to know that, for example, one metric is degrading so that the data you are generating is not that reliable as it was before, and so that you can maybe alert or notify the users that, hey, maybe we have some issues, maybe you should wait before using the data time we fix the problem. So besides, so next term is data discovery. In other words, how to be aware of new data. So there's different solutions. You can have kind of synchronization between producers and consumers, so that it's very well framed and everybody knows everything about everything. On the other hand, you may also have some different scenario where the producers are less synchronized or maybe are external to your system and you do not necessarily know what's happening and maybe when a new data is ingested to your system. And in data discovery, you will define these two words. So the word between the synchronization and the desynchronization. The words of synchronization. So it can be a format of data contracts or something like that between producers and customers, and the word of desynchronization, where you will more create a kind of data discovery jobs that can be called crawlers because they generally analyze your data set, maybe an object storage location or maybe a streaming broker, and depending on the rules and the knowledge these crawlers have right now, they might discover that, hey, there is no new data here, there is new entity we can process, so they will ingest it to the system and also update the metadata catalog with all this information. So the metadata catalog, which is a part of data governance you saw previously, because it groups all the data sets that are useful and shared by the data users. So now it's time for data profiling. So data profiling is kind of giving characteristics on the profiling, decorating data with attributes. So for example, you can, with this data profiling thing, you can know that some columns of your data, one column of your data set has, for example, only null values, or you can discover maybe the distribution of values and stuff like that. So have a much more fine-grained view at the data by creating these profiles. And the next term is a bit more DevOps-like because it covers all the automation and infrastructure management you as a data engineer may face in your data systems, and this concept is called data ops. In addition to that, we have also data ingestion, which is the process of bringing data from an external world to our system. So yeah, ingesting the data from that place to ours. There's also data exposition, which is kind of opposite because it consists of taking data from our place and exposing it to the world, to the internal or external customers. And data enrichment, which consists of kind of data set augmentation, because you add some extra attributes to the existing data set, or you maybe combine multiple data sets into a single one so that subsequent customers for this data set can have better experience and can do better insight from these data sets. So data enrichment consists of adding the data, and data anonymization does the opposite. So it removes the data from the data set, but it's not necessarily all the data. It's mostly related to the personally identifiable information, like for example address, first, last names, birthday, and things like that can really identify a person. And its usage is also very often related to any legal legislation. And finally, there is also data modeling, so the process of defining a structure for the data. So for example, a schema in a relational database. And yeah, I'm aware these are not all data-like concepts in data world, but if I had to present them all, I would need probably to create a dedicated module for them and built in with all these theoretical approaches and definitions. And believe me, there is no better way to learn something than by practice. And that's why I hope this time will be enough to start to understand the idea, but later in this course you will be able to see them in practice and understand them even better. Thanks for watching.